which is part of the line. It has an end point, and then it continues infinitely in one direction. Looks like that. When we name an array, the order of the letters matters. So this is XY with the arrow pointing towards Y, or if you wanted to put the YX, that's fine, but you have to turn the arrow around. The end point of the ray has to line up with the side of the arrow that doesn't have the arrow point on it. Okay, so the letter order matters. I could call this YX with the arrow pointing the opposite direction, but I can't call it YX and point the arrow in the same direction. Does that make sense? Okay. Opposite rays are when you get two rays forming a straight line, like that. So I have two rays, but they make a straight line. And then an angle is formed when you have two rays that don't make a straight line, but they share a common end point. So anything like this or like that. It could be almost a straight line, but it's not. Okay, we call the rays the sides. The end point that they share is called the vertex. And then you have the interior and exterior of the angle. So if I have an angle,
is that the side you're doing?
Yeah. So if I do this angle, I have side BA, that's one ray. Then this is side BC. B is my vertex. Anything in this area is in the interior, and anything else is exterior. And the interior continues, even though my angle picture stops here, the angle continues on forever. So anything in that V that goes on forever would be in the interior. So something right here would still be in the interior because this line would come up past it on this side. Does that make sense? Naming angles, because that's really important. So we're going to name all of the angles that have B as a vertex. So the first thing we need to do is find B, which is right here. If you want to. There's markers here if you need them. Okay, so B is our vertex. We have a couple of angles that are sharing B. We have the point here. B. Can't see the yellow either. Here, red. Nope, not red. Blue. Right there. That's okay. No, it's fine. Blue, can you see that?
Yeah.
Okay. So B is our vertex. So I have this angle here that has B as a vertex, and I have this angle here that has B as a vertex. Okay. I can use the numbers. Number 1 and number 2 are the angle numbers, so I can call the angle 1, and I can call angle 2. Or I can use the letters of the points on the rays. This is A, B, D. Okay. So what we need to be careful of is when you're naming an angle with the letters, the vertex has to be the center letter. That's very important. Okay, so these two the order of the two ends don't matter, but the vertex has to stay in the center. So I can call that ABD, or I can call it DBA. But the B has to be in the middle. Always. The vertex is always in the center. Okay? That way, what happens is if I later tell you angle ABC, then you know you do an angle, and this would be B and A and C. The vertex is always in the middle. Okay, so we've got the three names that you can call this angle, but we have now this angle, and this one has more than three names because there's more than three letters. So I have angle 2. Yeah, I'm just showing you all of the ways you could name it, because that way you can see all of the different possible ways so that you know that there's not one correct 100%. So I have B. This is my vertex still. I already called it angle 2. I have D, B, C. Yeah, or I can call it CBD. But on this same ray, I also have K and L. So I could use either of those instead of the C if I wanted to. I could call it angle DBK or angle DBL. And I could also switch the order on those, KBD and LBD. As long as it's on the same ray, yeah. What you have to do is you have to have the vertex be the center letter. And then you can use any letter on either ray that is from the side.
Could you do like ABL?
ABL would be this straight line, so that would not be the angle.
Okay, so it has a big angle.
Yeah, we're talking about the angles. And we have to have at least 3 letters or a number in the center. Now, you see how this number has like no degree marks? If it had like a that right there, that wouldn't be angle 1 anymore. That would be a 1 degree angle. That would be the measure. But if it has no degree marks and it's just a number sitting in there, it's also the name of an angle. So I can call this angle ABD or angle 1 or DBA. If it didn't have anything else on here, if it was like that, I could also call it angle B. But because B is for 2 angles, I can't. You can only call it by 1 letter if that's the only angle that if it's like an angle sitting out by itself. Does that make sense? If I have an angle that's just sitting out in space by itself, like this, I can call that with 1 letter. But because B is part of both this angle and this angle, it's connected to 2. So I can't just call it B, because if I say angle B, which one am I talking about? Does that make sense? So you have to use 3 letters in that case. Hold on just name the sides of angle 3. So we find angle 3. Angle 3 is this angle here. Okay, that's angle 3. So if we're naming the sides are going to be 2 rays. So C is my vertex. So C is going to be my first letter. Now I can call this CB, or I can call it CA, because I can call it, I can call it either of these 2 letters. And then when I look at this one, I only have 1 point on that ray other than C. So this one has to be CE. Does that make sense? So if you said CB and CE, you'd be right. If you said CA and CE, you'd be right. No, because we're talking about angle 3, which is this angle. So to figure out the angles based off the numbers, I'm going to erase this real quick. Okay, if I'm talking about the angles based off the numbers, if I look at, I want it at angle 2, okay? 2 is right here, it's this angle. 5 is right here, so it's this angle. 3, this angle, yeah, it's the one that it's inside of, it's the interior number. Okay, another name for GHL. Let's find GHL real quick. GHL, yeah? I can call it angle 7, or I can call it angle LHG. I can change the order of the letters around that center letter. As long as the vertex stays in the center, the other two letters can flip-flop. Okay, if we look at angle DBK, DBK, name a point in the interior. Interior is anything inside, so I only have one point on the interior here. That's point E. Questions so far on those? They okay? All right. The vertex of angle 5. Here's angle 5. My vertex is C. I have angle ECL. So let me highlight that. How about pink? Does pink work? Oh, that's not what I meant to do. I meant to highlight it pink. Is pink okay? No? No, okay. We have to find them. Oh, no, it's okay. We'll find colors that work. Yeah, this is, no, that's probably not good. She can't see green very well. How about, can you see this one, orange? That one's okay? Okay. Yeah, it's a darker orange, I think. Okay. So we're talking about ECL. I can name that angle 4 because the 4 is on the interior. I can change the order and name it LCE. I can take out the L and put in a K because they're on the same ray, so I could call it angle ECK, and then I could change the order of that one and call it KCE. So all of these would refer to the same angle, so if you use any of them, you'd be okay, as long as that's the angle you were actually talking about. Okay. We're going to name the sides of angle 5. Angle 5 is here. So we have CB or CA. Either one of those is acceptable as one side. And CG or CJ. Okay. And finally, we want to name a point in the exterior of CLH. So CLH. Now, if I extend this, it would go forever and ever that way. These points are on the interior. These points are on the exterior. Anything that's actually on the lines don't count as interior or exterior. They're considered to be on the angle. So if I'm talking about the exterior, I can have D or E. And then if I had asked you about interior, it would be J or G. After we've named our angles, we can classify them. Okay, we have right angles, which are exactly 90 degrees. This symbol right here, oops, wrong color, sorry. This symbol right here tells me 90 degrees. So if you see a little box in the corner, it's 90 degrees. And an 89.999999999 degree angle is still not a right angle. It has to be exactly 90 degrees. An acute angle, yes, yes. And there, you can remember that an acute angle is less than 90 degrees because they're little, and that makes them cute. Little things are cute, right? Think about like puppies, kittens, little tiny miniature horses. Little, cute, acute. And then anything bigger than 90 degrees is considered to be an obtuse angle. And it's actually greater than 90, but less than 180. 180 degrees is a straight line. So we no longer are talking about an angle at that point, we're talking about a line. Yeah.
So it can't, an angle, as far as this goes, it can't exceed over 180 degrees.
Not really. It's, as far as where we are at this level. Yes, you can measure angles greater than
I
180.
know it can go to 360, but once it hits that flat line, you're
Yeah.
just dropping back from 180 back down to 0 again.
Yeah, because let's say if we have, there's the 180 and I go this way,
It's still a
I'm not going to measure this outside ring, I'm going to measure inside. And we're going to, our angles are going to be limited between 0 and 180. And once we hit 180, we're at a straight line. And 0, we have a ray. Okay, so to measure angles, so if I measure this, it's 75. And that makes it acute. Okay, LJP, see how it has this box here? Yeah, so I don't have to measure it at all. It's 90 degrees, right? And then NJP is this small one. So again, I'm going to have to measure that. Yeah, it should be less than 90, but I'm going to also measure it. And it is 15. So that one would be acute. Now, if you're looking at this, I didn't ask you to measure this, but can you see what angle might be obtuse? KJM. Because if this one is 90 degrees, this one will also be 90 degrees. So, yeah, obtuse angle KJN and great, yeah, or KJM. Those would be greater than 90. So those would be obtuse. So any angles that have the same measure, so all 20-degree angles are congruent to each other. All 40-degree angles, 157-degree angle is congruent to another 157-degree angle. And the symbol for congruent is still the same as when we talked about segments. So we had congruent segments, we can have congruent angles. Basically, congruent is just a catch-all phrase for things that are the same size and shape. An angle bisector is a ray that cuts an angle into two congruent parts or halves. So if I take an angle and I cut it in half, so like here, and then this is my bisector, then that would mean that this angle and this angle would be the same. If I didn't draw it that way, but that's what it would mean. If it's a bisector. If you can have an interior ray, that's just any old ray cutting it into any sizes, but if it's a bisector, it cuts them into two equal pieces. So we can use that with this next problem. I have Kn, so if we look at Kn is this one right here. Okay. Kn is bisecting JKL. JKL is this one right here. Okay, so what that's telling me is that this angle and this angle are congruent. They have the same measure. And since they both have, one, that's the symbol for that. If JKN, So JKN is 8x minus 13, sorry. And NKL, so NKL is 6x plus 11, and I want to find how much that is in degrees. So the first thing I need to do is find x. Right? Well,
Can you just make them equal to each other?
yeah, they're equal, they're congruent, so I just make them equal to each other and solve it. Is that too fat? Or is that better? Which is
I
better?
like that better.
That's better? Okay. So I'm going to subtract 6x from both sides. So I get 2x minus 13 is equal to 11. Then I'll add 13 to both sides. And that gives me that 2x is equal to 26. Divide by 2. And x will be 13. Yeah. But see, I don't want to know x. I want to find JKN. Yeah. 12. No, 13.
Yeah,
Oh, 24. You're right. You know what happens when I have a bad day and then the good news happens? I can't add anymore. You are absolutely right. However, I was correct that 26 divided by 2 is 13. I just was not correct that 11 plus 13 equaled 26. Now we want to find JKN. JKN is equal to 8x minus 13. X is equal to 12, so that's 8 times 12 minus 13. So that is 96 minus 13, which is 83. Did I do all that right? Okay. So degrees though. The x won't have degrees because it's just the value of x, but the whole angle measure will have the degrees on it. So JKN is 83 degrees. Example, we're still bisected. So this angle and this angle are still congruent. But in this example, I have the measure of JKL. That is this entire thing. Does the purple? No. I'm just going to use a different blue. This entire thing is 9y plus 15. Okay. I'm not going to subtract. But we have to have it equal to something.
Oh, so 5y plus 2.
Well, this one, yes. We have these two angles are the same. So multiply it by 2. Because 2 of them equals the whole thing. Okay. Then that makes this also 5y plus 2. So this will be 10y plus 4 so I get y plus 4 equals 15, which gives me y equals 11. But I want to find JKL. And JKL is 9y plus 15. So 9 times 11 plus 15. So 99 plus 15. So 114 degrees. Angles. If you're adjacent to something, you're next to something. So adjacent angles are two angles that are glued together at one side. So if I have, like this, angle 1 and angle 2 are adjacent to each other. Or I can have even something like this, where angle 1 and angle 2 are, so basically you take two angles and you glue them together at a side and you have adjacent angles. They don't share any common interior points though, so if I were to draw an angle similar to the first example of 1 and 2, but I don't have angle 1 and 2, what I have would be angle ABC and angle 3. They're not adjacent. Okay. Angle 3 is inside angle ABC, not next to. Does that make sense?
If angle 3 had been like if that line had been a letter, would they have been adjacent?
This line here?
Yeah, that would be
Yeah.
like line D.
If I made this line D, ABD would be adjacent to DBC, but ABC would not be adjacent to either of the little angles. The adjacent angles can only be stuck together at the sides. They can't be inside one another. Another thing that gets confusing that people might think was adjacent is if I have this line right here and I stick two different angles on it, these two angles, angle 3 and angle 4, are stuck to the same line, but they're not stuck to each other. So they're also not adjacent. They share a line, but they don't share a common side and a common vertex. Does that make sense? Okay. When you have a linear pair is a set of adjacent angles that make a straight line. So if I have any two angles that happen to be adjacent that make a straight line going in any direction, that's a linear pair. If it's even a little bit of not a straight line, not a linear pair. Linear pair, I mean, I realize that the line I drew wasn't straight, but pretend it's straight.
Like they have to
Equal 180, yeah. Whenever you have two intersecting lines, so two straight lines intersect, they make an X, and then you get two pair of vertical angles. This angle is vertical to that angle. Or, you know what, let me do this. Angle 1 and angle 2 are vertical. Also, angle 3 and angle 4 are vertical. So the angles that are across from each other are vertical. The angles next to each other are adjacent. So I have 1, 2, 3, 4 sets of adjacent angles, and then 2 sets of vertical angles. You only get vertical angles if you have two straight lines. So if I have one straight line and then another kind of broken line or something, that's not vertical. It has to be two straight lines intersecting to be vertical. I know my broken line didn't line up quite right. Still didn't line up right. I can't draw today. Not vertical. Okay. And we can identify these. Acute adjacent angles are going to be less than 90. So each one of these, I'm going to go ahead and number them just because that'll make it easier to talk about some of them. Okay. Acute adjacent angles. All of these 6 angles are less than 90 degrees individually. So I could say angle 1 and angle 2. I could say angle 2 and angle 3. Angle 3 and angle 4. Angle 4 and angle 5. angle 5 and angle 6, and angle 6 and angle 1. So do you see these would be adjacent, 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 and adjacent. Yeah, these are all acute angles individually. If I combine them, I can make 2 circles. Vertical angles occur when you have an X. Here's my X. My obtuse vertical angles are H, J, N, and K, J, M. Or I could say N, J, H, and M, K, J, K. Linear pair is any 2 angles that make up a straight line. Well, I have a straight line here. I have kind of 3 angles technically that make this up, so I can use any 2 bigger angles. So I could use N, J, H. I forgot to put my little angle mark. And angle 6, right? So N, J, H, and angle 6. Or I could use angle 2 and O, J, K. So that would be the 2 linear pairs that make up this straight line. Or if I wanted to talk about this straight line, I could talk about angle 6 and K, J, M. Or I could talk about angle 4, right? This, and L, J, H. Okay. Then my acute vertical angles are across from each other. So I have angle 6 and angle 3. Vertical angles are congruent, so the angles across from each other have the same measure. So if this is 110, this is 110. And if this was 110, these are linear pairs, so that would make this 70. And if this one's 70, that one's also 70. Then you have complementary angles, and those are 2 angles with a sum of 90 degrees. Now these can be angles that are adjacent to each other, or they can just be 2 random angles off in space. Like you could have an angle in that corner of the room and an angle in that corner of the room, and if they add up to 90, they're still complementary. And a good way to remember complementary is if somebody compliments you, they are right. And right is 90 degrees. So compliment, if you get a compliment, they're right, and that's 90 degrees, so complementary angles add up to 90. They don't have to touch each other, they just have to add up to 90. Supplementary is very similar, except instead of 90, it's 180. So any 2 angles either touching each other or in 2 different places in space, if they add up to 180, they're supplementary. Then you get a linear pair, and if you recall, a linear pair are adjacent angles that form a straight line. They are also supplementary. So they add up to 180. And linear pair and supplementary can sometimes get confused. They both add up to 180. Supplementary angles don't have to touch. A linear pair have to be adjacent, so they have to actually be touching. That's really the main difference between the 2. I'm going to finish this little bit and then we'll finish the rest later. Everybody got these? we're going to find the measures of two supplementary angles. So supplementary, this tells me right here that the sum is going to be 180. Okay. Make that a little fatter. The difference in the measures of the two angles is 18. Difference. Subtract. So if I say one angle is x, what is the other angle going to be?
Well, it's gonna be x minus 18.
Or you could use x plus 18 if you want to do that. The difference is 18, so I can say either one is, if x is the large one, then x minus 18 will be the smaller one. If x is the small one, then x plus 18 would be the large one. Do you see how that would work? So either way, but what I'm going to do is, if I'm using plus or minus here, that doesn't matter as long as I have the two added together to equal 180. And then if I say 2x minus 18 equals 180, and then I'm going to add 18 to both sides, or if I was using subtraction, I will subtract 18 from both sides, or, the other way. 2x will equal 198, which I will divide by 2, and that will give me an x of 99 degrees. Yeah. So and you can check yourself. They have to add up to 180. So when you find your two angles, if you add them together and they equal 180, then you're good. They're supplementary. If you made a mistake, like let's say you divided 198 by 2 and you didn't say 99, you said 98, then that would have given you 81, it would have given you 80, and then you would have said 98 plus 80, and you would not have gotten 180. So it's easy to double check yourself on these. And we'll stop here.